So, as I said, our topic is a cloud and DevOps. It's a combination of a cloud and DevOps. DevOps is nothing but the development and operations. Okay. So, ma'am, do I need to switch on the video? Is it necessary?
No, ma'am.
Okay. So, the IT landscape is changing rapidly. The way we build, deploy, and manage the software is fundamentally different than it was even 5 years ago. Okay. Previously, we have a traditional IT. Now it's a modernized. So the way organization deliver a value is fundamentally changing and moving from slow manual process to rapid automated systems. So this transformation is driven by the synergy between a cloud computing and DevOps methodologies. So we are here to understand not just the tools, but the cultural evolution required to accelerate the software delivery and improve reliability. So this lecture aims to bridge the gap between the traditional IT practices and modern efficient cloud native approaches. So we will explore how the leveraging cloud computing alongside DevOps principles that creates a powerful synergy that is reshaping the entire industry and why the modern organizations are rapidly moving to the cloud. That's a transformation of cloud DevOps. How DevOps accelerates delivery and how the technologies like automation, containerization, there in the DevOps, and Kubernetes. So make an infrastructure scalable, reliable, and future ready. So this talk is structured like a transformation journey, right? From fundamentals to real world implementation. So the goal by end of the session is for you to understand why and how of this transformation be equipped to start your own journey. So basically, the cloud and DevOps transformation refers to the strategic process through the which organization modernize their IT infrastructure, the application development methods, and the operational practices using the cloud technologies and DevOps culture. So in the session, we have roughly 2 hours together. We'll see all the details one by one in upcoming slides. So why it matters, like the transformation for a modern infrastructure, why it matters. So traditional IT delivery is slow and expensive. So because it needs a lot of manpower, we needed different members or different teams for developing some product. Okay. So digital transformation demands a speed and scalability, mostly the automation, security and resilience. So here the cloud and DevOps helps organization to innovate quickly and maintain the competitiveness. So is the agenda of the today's session. Here is the roadmap for the next 2 hours. So I have structured this into the 3 main modules. Initially, we'll cover the foundations like a problem with traditional IT, the definition of cloud computing, the core philosophy of the DevOps. So it includes the core philosophy of DevOps include the 3 ways. We'll see this. In the second module, we'll dive into the specific practices and principles that enables this transformation like CI/CD. So it's nothing but the continuous integration and continuous deployment pipelines, infrastructure as a code IAC, and the automation, and obviously the containers and Kubernetes. So ultimately, in our third module, we look at the practical roadmap for adopting these practices within an organization, along with some real world case studies. Okay. So of companies that have done this successfully, though the companies who transformed the traditional IT to a modern infrastructure, like cloud and DevOps. Also, we'll see monitoring part and the cloud DevOps security. So separate cloud security and separate DevOps security, and together we'll see. In this, each part builds on the previous one. Like the first cloud basis in the module 1, DevOps in module 1, and module 2 we'll see the automation, containers, and Kubernetes, and in module 3, security, enterprise, and roadmap. So by then, you will understand the full life cycle of a cloud and DevOps transformation. So traditional IT culture and the silos problem. Okay, it's a need for change from traditional to a modern infrastructure. So let's start by looking back how the things used to be in the many organizations. So traditional IT was often characterized as a silos, like isolated teams. We have a different teams for a different work. So everyone knows the software development life cycle, right? So you have a different phases in the development cycle, like requirement gathering, and then communications. Okay. So analysis and design part, coding part, testing part, and finally monitoring or deployment, maintenance part. Okay. It's uh, it's a traditional IT cycle. So traditional IT scatters the silos like isolated systems. So each and every departments have doing will do their own work. Okay, so our data depositories that hinder the communication and collaboration within the organization, that mostly leading to the inefficiencies, inconsistent information because the lack of communication among the team members, right? So on the fragmented view of operations, so they occur at the technological and organizational levels, like technological in the sense servers, applications, and storage, anything. So in the organizational levels means nothing but a marketing team, sales, development team, often causing a duplication of effort and missed opportunities. Here, duplication is means with the lack of with the lack of communication, the same work or same product will be handled by the different team members, or they will miss to handle the work. So in traditional IT, you had a development team. Their primary goal was to introduce the new features and innovate quickly. And then you had an operations team whose goal was a stability, uptime, and minimizing the change. So these goals were fundamentally at cost, which lead to the manual process, like throw it over the wall, like it's there in the slide diagram. So development team so work to operations or operations to develop. So this image is an example for the DevOps. It contains only development and operations. So these goals were formula that's related to the manual process, right? So the market demands today are much faster. We need agility, speed, and resilience. So this traditional model simply can't keep up with the modern business strategy. So modern business and modern infrastructure, we need advanced things. Okay. So we shouldn't stuck with the traditional IT. So we need a better way to align these functions. So next we'll see we're going to the cloud and DevOps topic together. We'll see what is a cloud first. So it is a utility computing model on demand access to shared resources over the internet. So the cloud and DevOps transformation to modern infrastructure, the first half of our solution is a cloud computing, right? So the cloud is not about so the cloud is not about treating the computing infrastructure as a utility. Is my screen visible?
Yes, ma'am, but your video camera is off.
Okay, okay, good.
Yeah. Hello, ma'am.
Wait, wait, 1 second.
Okay.
Is it okay now? Am I visible?
No, ma'am. If have a technical issue, is it okay?
Wait, ma'am. So stuck. This is- Am I visible now?
Yes.
Or like system hand. Is my screen visible, ma'am? It's there in the previous slide.
Yes, yes,
What is cloud
yes.
computing? Okay.
Yes.
Okay. So as well the PPT, we have some key characteristics of a cloud computing, NIST. So it's nothing but the National Institute of Standards and Technology. So basically, the cloud computing is a technology that provides access to the shared computing resources like storage, databases, networking, and software over the internet. So it enables the users to store and access data and applications remotely without managing the physical hardware directly. It's like with the help of a virtualization. So think of it's not just someone else's data center, but as a utility model for a computing resources. Okay. So the on-demand access based on the user need. So the cloud service providers will serve the resources. Like you can access the servers, storage, and services instantly over the internet, paying only for what you consume. So the key characteristics here are on-demand self-service, rapid elasticity, resource pooling, broad network access, measured services. So here the on-demand self-service, nothing but you can choose your resource. You can provision the resource instantly. And rapid elasticity has been scaled up or down automatically based on the user needs. If you want more storage or more resources, you can scale the resource up and down. And for that, you have to pay for the service provider. Next, resource pooling, the shared and scalable infrastructures. Okay, so the broad network access, so you can access it from anywhere, but we need an internet for that. Okay, you can access it from the remote location. And finally, measured service, pay per use model. So you do no need not to pay for all the resources. So whatever you are using, you can pay for those resources only. So here the elasticity and speed fundamentally changes what is possible. And moving us from rigid long-term infrastructure planning to dynamic or responsive infrastructure. So, and next is the value of cloud. Why we are moving to cloud? It's changing or not? Speed, flexibility, resilience, and innovation. So the companies move to cloud for the multiple reasons. For example, the big company, Netflix, that handles the massive traffic using the cloud scalability. So it scales the resource up and down based on the traffic. Some startups avoid the upfront hardware cost. Applications can be deployed globally in minutes. So the business gate entity updates happen in hours, not the weeks. Okay. So some are doing business, if or in traditional IT or something, if the update happens, manually we have to update. Okay, it takes hours, weeks or days, something. Okay, so the value proposition is compelling. It's not just about saving money on the hardware, though that is a benefit. So here the real value is a speed and agility. So speed, the provisioning in a minute, not a weeks, and flexibility, it's a dynamic scaling, pay as you use. And resilience, but in reliability and disaster capabilities, built-in reliability and disaster capabilities. So whenever the system fails or any disaster happen, we have to recover, right? So it's a mean time to fail. And the innovation, access to advanced managed services, AI, ML, and DB. So as you know, what is the AI and ML and DBs? So this accelerates the experimentation and innovation, and also it democratizes the access to advanced services like tools and massive storage capabilities. So the cloud provides a flexible foundation necessary to implement the modern practices. So next, we'll see the cloud service models. So the basic three services are IaaS, PaaS, and SaaS. The infrastructure as a service, platform as a service, and software as a service. Here, the infrastructures provide the virtualized infrastructure resource like compute, storage, and networking over the internet. So, as you know, we need internet to access the cloud. So, in infrastructure, it replaces a physical data center with the cloud-based resources that can be scaled on demand. Here, the examples are AWS EC2, Amazon Web Service EC2. Another example is Google Cloud Engine, Microsoft Azure, and DigitalOcean. So, when we need an infrastructure as a service, so if you want to host the websites or if you want to host some enterprise application, for example, you have already created a website and you have already created the application, but you need some infrastructure to host the website or a application. So, and storage and backup solutions. For that, we need an infrastructure. So, running test and development environment. So, as I said before, you have a website or application with you, you need to test that application. Okay. So any testing, if you want to do, you have to deploy, you have to host the website in the infrastructure to check whether it's working or not, testing. Sometimes we need an infrastructure as a service for high performance computing and the big data analytics. So next is the platform as a service. It provides the tools and environments for the application development. Here are the examples in the PPT are the Google App Engine and Hero. So platform as a service provides a cloud-based platform with tools and services for application development and deployment. So in infrastructure, you already created application, you need some infrastructure to host. Okay, you already have a website or application, you need infrastructure to host. But in platform, you can use the platform to develop and deploy the application. So here the developer focus on building apps without managing a server, storage, or a runtime environment. So because the infrastructure that provides a servers and storage, right, to host the website. So here the platform that uses the platform as a service, you can use the platform and you have to pay for that. Here the use cases of the platform as a services are web and application development, building APIs or application testing and deployment. Collaborative software projects. Okay, if different teams are needed to build a website or application, they can use a platform as a service. They can use a cloud-based platform to work together. Okay, so you can access it in fact using a virtualization, a remote, virtualized environment you can create. From that, you can work together with your colleagues. The next service is software as a service. Ready to use application delivered over the internet. So example, Gmail, Google Workspace. So users simply log in and use them without worrying about the installation, updates, or infrastructure. So Gmail workspace, or you can tell Zoom. We are now having the lectures in the Zoom. Okay, it's a software as a service. They provide the software. We are using the software. We don't need to create or install something. We don't need to develop the application, right? So from some examples of Gmail, email, file storage, sharing. You're using Google Drive, or you're using a mail. You're sharing that document with your friends and the colleagues. So customer relationship management, project management for collaboration tools, video conferencing and communication apps like Zoom, Microsoft Office. These are all the software as a service. In simple terms, some of them say it's a pizza analog. So for IaaS, if you want to eat the pizza, so here the IaaS, infrastructure as a service, you buy a ready-made pizza, take it at home and bake it yourself. Okay. So platform as a service, you buy a pizza by someone else, and you provide a drinks or setting something. And software as a service, so you go to the restaurant and everything is provided for you. You simply eat the pizza. Okay. In simple terms, you can say the infrastructure as a service is like raw ingredients. So you control everything. So you have everything. You use their server storage, and you host your website. And platform as a service, it's a semi-cooked. Okay, you build a ready platform. You build on a ready platform, and software as a service is ready to use. You just log it and use it. So understanding these models helps architectures choose the right level of control. Okay. Next is cloud deployment models. So we have different cloud models. You have to choose one according to your need. Is my PPT visible? It's a cloud deployment models. DevOps. So we have 4 deployment models: public cloud, private cloud, hybrid cloud, and multi-cloud. One more cloud is the community cloud. I have not included this in the PPT. So public cloud is operated by the third-party providers, are scalable and cost-effective. And private cloud is dedicated infrastructure for one organization. It's high security. And hybrid cloud is a combination of public plus private cloud, most common enterprises. And multi-cloud is use of multiple cloud providers to avoid a vendor lock-in and implementation. So the first, we'll see the public cloud is managed by the third parties, which provide the cloud services over the internet to the public. These services are available and pay as you go billing method. So the fundamental characteristics of a public cloud are multi-tenancy. So multiple users can use those public cloud at the same time. So it's been to serve multiple users, not a single customer. Okay, so open to all the customers. So user requires a virtual computing environment that is separated and likely isolated from other users. So especially cloud computing is one of the characteristics is the multi-tenancy. So multiple users can use that cloud. In public cloud, anyone can use and operated by the third-party providers. So public cloud also have a pros and cons. So some disadvantages and advantages are there. The first big advantage is the public cloud is easily able to scale up and down the resources as per the demand of traffic and overload. So at a time, a lot of users are using that particular public cloud service, the more traffic will be happen. So on the time, the public cloud is easily able to scale up and down based on the customer or user resources and demand. So it works on pay-as-you-go cloud model and helps in resolving the investment, the needs in the hardware, infrastructure, and it reduces the overall cost. Okay. So disadvantages. It is difficult to trust and maintain the data of the third-party provider. So it's handled by the third party. If you're giving some personal information to the public cloud, it's not safe, right? So the shared infrastructure of a public cloud resources increases the risk of data breaches, unauthorized access. So if it is not secured properly, someone may misuse our data, the data will be leaked. So public cloud comes with a limited transparency about the underlying infrastructure, which may make it challenging to monitor and manage the performance effectively. So it's one of the security is one of the major disadvantages of a public cloud. So next we'll go to the private cloud. It's a dedicated infrastructure for one organization. It's highly secure. So private clouds are distributed systems that work on the private infrastructure and provide the users with the dynamic provisioning of computing resources. So instead of pay-as-you-go billing method, the private cloud could be other schemes that manage the use of a cloud and proportionally billing of different departments. For example, in a college, we have a different departments, right? So each and every department. So for example, in public cloud, if you use some resource, you have to pay for that. But in private cloud, the proportional billing of a different departments, right? Usage of a cloud. On private cloud providers or HP data centers, Ubuntu, Microsoft, these are all the private cloud providers. So some of the examples are VMware. So if you're working with some virtualization, you install VMware Oracle, okay, to virtualize a different environment, right? So OpenStack, Cisco, HP, these are all the private cloud providers. So in private cloud, there are also pros and cons. First main advantage is security. It is highly secure when compared to the public cloud. And the customer information protection. So the cloud security concerns is less since customer data and other sensitive information do not flow out of the private infrastructures. So the organization, we need some expert or some experts. We need some expert to manage and monitor the private cloud. So within the private infrastructure, the sensitive information don't flow out. The infrastructure ensuring the SLAs, like a service level agreements. So the private cloud provides a specific operations such as clustering, data replication, monitoring, maintaining, disaster recovery, and other uptime services. Especially disaster time, if any failure happens, you need some backup. Okay, so based on the backup, you can recover the system. So the compliance is standard procedure operations have to be put in place when deploying and executing the applications according to the third party. So I said that one of the advantages, your information do not flow, do not leak. This is also one of the disadvantages. So the restricted area of operations, it is accessible within the particular area. So the area of accessibility is restricted. So expertise, like in the private cloud security, the concerns are less since the customer data and other sensitive information do not flow out. So skilled people, we need some skilled people or we need some expert to manage and operate the private cloud services. So next one is hybrid cloud. It's a combination of a private cloud, private and public cloud, most common for enterprises. So it's a heterogeneous distributed system formed by combining the public and private. So the major drawback of a private deployments is the inability to scale on demand. So in public cloud, based on the user demand or user need, you scale up and down. In private cloud, it's a fixed resource. We can't scale up and down by our own. So, okay. So to overcome this drawback, the hybrid cloud comes to the picture. It's a combination of private and public. Okay, the public clouds, Based on because of the inability to scale on demand, they efficiently address peak loads. Here the public clouds are needed. The hybrid cloud take advantages of both. Sorry, hybrid cloud takes advantages of both private as well as the public. So some examples of AWS, Azure, Stack, Google, and those IBM. And some of the benefits here, the hybrid cloud is available at the cheap cost than the other clouds because it is formed by the distributed system. So as you know, it uses a distributed system principle where data and workloads are spread across a multiple interconnected. So it's a cluster of work, right? So the data and workloads are spread across a multiple interconnected. It's in the distributed system. The components run on different machines but communicate seamlessly in a single system. Okay. So one more thing. The parallel and distributed system is a base of a cloud. Okay. So we are processing we are processing the data parallelly among a distributed different systems. So however, hybrid is combining both the public and private. However, it's totally safe and secure, but it is one of the misconceptions. So security totally depends on proper configuration and controls. If you are not configured the hybrid cloud properly, there is a leakage of data only. So the private cloud provides a stronger control over sensitive data, while public offer a scalable resource. So we have to combine the public and the private to use the resources. Okay, so in distributed resilience, if one node fails, other continue functioning, reducing the downtime. So overall, it is a highly secure. For that, we need a continuous monitoring and proper governance. So I have not included a community cloud in this, but you should know about the community cloud. So it's a distributed system created by integrating the service of different clouds to across the specific needs of an industry or a community. So for example, multiple colleges or multiple companies comes under the same community. They use a single, they use the service of a different cloud to address a specific need. In community cloud, the infrastructure is shared between the organization that have a shared concerns or task. The organization or any company or any, you can take a university or a college that comes under the same community, they can use the community cloud. So it's on an organization or a third party may manage the cloud. Examples are Cloud Sigma, Nextcloud, OneCloud. Okay. So some of the advantage of using the community cloud, the entire cloud is shared by the numerous enterprises or community. It works with every user. It's adaptable as well as scalable. So users can alter documents according to the needs and requirements. So we have to thank the community cloud. So we may share the cloud resource infrastructure between the different enterprises. It also has some disadvantage. Like it allows it not all business uses a community cloud. Since there is a should choose community cloud. So it's a challenging of a corporations to share the duty. So for example, multiple corporate companies or multiple organizations using the community cloud, it is challenging or difficult for that organization to share the duty. So which duty will be handled by which organization, which duty handled by the different organization. And the final one is multi-cloud, the use of multiple cloud providers to avoid the vendor lock-in and improve resilience. It's a multiple cloud services from different providers. We have a Kubernetes, we have a Apache, we have a Red Hat. So we can get the services from a different providers, which allows the organization to use the best suited service for specific needs. So single organization using the resources from the multiple providers. Okay, so this all allows the organization to take advantage of different features and capabilities. Okay, so these are the basics of a cloud. So without knowing the basics, we can't jump into the DevOps. That's why I said basics of a cloud. So hope you understand what is a cloud and what are the services are provided by the clouds and what are the deployment models. Okay, so next we'll go to the DevOps. So DevOps, a cultural engineering and methodology aiming to shorten the SDLC and provide a continuous delivery. So software development lifecycle. So the major phases of a software development lifecycle is requirements gathering, like a communication phase and planning and designing or analysis and design. Next is coding, next is testing, and finally a deployment and a maintenance. here, so first we have seen cloud computing. This is the first half of our solution, and the second half is DevOps. Like transforming the modern infrastructure, we need this. So DevOps is often misunderstood as the automation or a job title. It's a cultural shift. It's a combination of software development and IT operation. Okay, DevOps, development plus operation. So core principle comes framework. It's a CALMS, culture, automation, lean principle, measurement, and sharing. So the key pillars, these are all the key pillars. It's about removing the walls between dev and ops teams. So we have seen such one diagram in the introduction page, I think. So left hand side, there's a development, and right hand side, there is operation. There is a wall in between them. Okay. So you have to remove the walls, and development team and the operation team have to work together and creating a shared responsibility for entire service life cycle from initial idea to production maintenance. It's a cultural shift, right? So communication, collaboration, shared ownership of the application life cycle from commit to production attempts, like from starting to deployment and maintenance. So there are 3 ways of DevOps. So it's a great way to conceptualize the DevOps through the gene key. Okay, so the 3 ways. Is my PPT visible? So at the page,
Yes.
the 3 ways of DevOps gene key. Should I continue?
Yes, ma'am. Go ahead.
So the 3 ways of DevOps by Gene Kim. He is a prominent researcher, author, CTO known for popularizing the DevOps concepts through some books. And DevOps Enterprise Summit, the studied the high-performing IT organization over 25 years. So he said there are 3 ways for the DevOps. The first way is flow, and second way is feedback, and third way is continual learning or experimentation. So first, you can see this is the diagram, Dev and Ops. It's a system thinking. It's optimizing the value stream to ensure the work moves quickly, smoothly from development to production. This involves like a CI/CD, like a continuous integration and continuous deployment, and smaller batches of a size of work. So second way, it's a feedback, amplify the feedback loops, like monitoring rapid learning. So development, operation, again development, operations. Based on the feedback, the loop continues. And the third way, the continual learning and experimentation, culture of monitoring and observability. I will tell. I'll tell this in upcoming slides, because just now we have started the DevOps, right? So if you have any questions, you say we will have a separate session for question and answers, okay? So optimizing the value. So about accelerating the entire process from left to right, like development to operation through testing and deployment. So left to right means starting, we have to plan and code, test. From left to right, we have to start. This requires breaking down work into smaller batches, smaller commits, and creating the automated pipelines, the continuous integration and continuous deployment to move those batches quickly. So this is the first way. And second way, based on the feedback, you have to monitor and rapid learning. So building the tight feedback. So for example, if something goes wrong in the production, that information must rapidly flow back to the development team. So the flow goes from the development to operations. So to start from the left to right, if anything happens, anything go wrongs in the production, the information must rapidly flow back to the development teams based on the feedback, so they can learn and adopt the changes quickly. So the problems in production rapid flow, allowing the quick correction and the learning. And the third bit is the continual learning and experimentation, where failure is learning opportunity. Psychologically, safety is high. So the experimentation is encouraged to constantly improve the process. So it's about being to fail safely, learn from the mistake without a fear of punishment. If anything going to fail, you have to learn from the failure. You have to experiment the new things. So these three ways are described by the Gene Kim. Okay. So why we need DevOps first? So why it matters? The results of adopting the DevOps practices are not abstracts. They are quantifiable business advantages. So the state of DevOps report consistently shows that high-performing organization deploy code several 100 times more frequently than the low performance. So some of the basic metrics is sorry, the DevOps report based on that it's a business value. So based on that, we can say why the DevOps needed in the business, why it is required. Okay, deployment frequency, how often the code is successfully deployed to production, lead time for changes, how long it takes a commit to get into production, mean time to recovery, MTT, how long it takes to restore and record services from an incident, change failure, the percentage of deployments causing the failure in production. So they also have a significantly faster recovery times from the failure, much lower change failure rate. Recovery time should be higher and change failure rate should be lower. This translates directly to better customer satisfaction, reduced operational costs, and ability to out the innovate competitors. So the competitive is necessity in the today's digital economy. So overall, with the business, if you connect DevOps to the business goal, the benefits of faster time to the market, it definitely will improve the customer satisfaction and increase the reliability and stability. So some major companies will see this in the case study, the Amazon and the Netflix, that uses the DevOps for the rapid deployments. Next, I'll see the continuous continuous DevOps lifecycle. So this diagram often called the infinity loop. It starts from the plan, code, build, test, release, deploy, operate, and monitor. Again, the loop continues. Let's see the continuous nature of a DevOps. It's not linear project plan, but ongoing cycle. It replaces a linear waterfall model. So waterfall model we have seen in the software development life cycle, right? It's a traditional way. So in the waterfall model, if you complete the first phase, you can't go back to the second one. If you plan and code, you can't go back to the planning phase, right? So it replaces a linear waterfall model. We see in the SDIC, we start with the planning and coding, move through building, testing, release, deploying. It's like a iterative model. Okay. So essentially the feedback from the monitoring and operate stages flow directly back to the planning and coding stages. So every stage is automated as much as possible, ensuring the continuous flow and rapid iteration. So when you complete the whole product, like you plan for the product and code, you build, you implement it and you test and release the product. After that, you deploy and operate based on the feedback. You have to improve your product. So you have to get the requirements and you have to plan accordingly. So it is a iterative process. Okay, it's a basic, basic important phases of a DevOps life cycle. So next, DevOps, cloud DevOps synergy, the enabler and the methodology. The cloud provides programmable infrastructure, APIs, and elasticity, and DevOps provides the practices, automation, CI/CD to leverage the cloud effectively, the foundation for a modern and dynamic infrastructure. So in this, we put together cloud and the DevOps. So it enabler the methodology, two pieces together. First, cloud is an enabler and DevOps is a methodology. So we have seen the basics of a cloud and basics of a DevOps. So I have to put these pieces together. So cloud platform provide the APIs, right? APIs, it will give APIs. You can scale up and down like elasticity and provision infrastructure programmatically. So the DevOps provides the practices like IAC. It's infrastructure as a code and automation and continuous integration and continuous development. And to leverage those APIs for automation, you can't achieve a true modern DevOps with the traditional data center, right? So for modern infrastructure, we need a DevOps. In traditional data center, we can't achieve these things. So that requires the manual provisioning. So the elastic on-demand nature of a cloud platforms like AWS, Azure, and GCP, and the design especially for a dynamic workflows requires a DevOps. So for continuous integration and deployment like CI and CD, the automating the build test and the deployment process reduce the manual intervention, helps maintain the consistent software delivery pipe. Second one is the infrastructure as a code. We automate the infrastructure provisioning and management. Once again, ma'am. பண்றேன் மேம். Ma'am, 1 minute, ma'am. 1 minute.
Yes.
So I'm back. Thank you for the waiting. Sorry. Am I audible, ma'am?
Yes.
Sorry for the interruption. So it's in the cloud DevOps synergy enabled the methodology. So in this practice, we have a CA and CD, right? So automating the build, test, and deployment process to reduce the manual intervention. For that, we did DevOps. Next, infrastructure as a code. By automating infrastructure, provisioning, and management, teams can create software environment using the predefined templates. So reducing the configuration error. So if you use the predefining templates, we can use the if we use the infrastructure, it reduces the time as well as the configuration error. Next is automation. So utility test or utilizing the test automation tools like Selenium tools, popular testing tool can improve the test coverage, accuracy, and speed, which is minimizing the human error in the testing phase. And fourth one is monitoring and feedback. Someone asked that's in the chat, right? Monitoring and observability. So automate. I will just tell the overview here. We'll see the monitoring and observability in the upcoming slides. So automated monitoring tools can detect the issues in software and hardware early on, helping teams address potential problems before they escalate. And final configurations allows centralized control of the configuration settings across the different environments. Next, we'll see the infrastructure is one by one. So ISC, managing infrastructures, VMs, networks, DBs, JSON, and instead of a manual process. So benefits or the version control, consistency, repeatability, elimination of configuration drift. We can use the tools Terraform, Ansible, and CloudFormation is a sample Terraform tool. So a cornerstone practice made possibly by the cloud APIs is the infrastructure as a code. So managing and provisioning the infrastructure. Overall, the networks, virtual machines, and the databases using the machine readable definition like a JSON. And rather than the physical hardware configuration or manual comments. So we no longer manually click the buttons, right? So fully automated, we no longer manually click the buttons in the console and set up the servers or the databases. Instead, we write the configuration files tools using this tools like Terraform. That define exactly what our infrastructure should look like. So these files are stored in the version control or like a Git, treated like an application code. So some benefits, as I said, the version control elimination of a configured drift. We get a repeatability, traceability, and disaster capability. So we are using the code repeatedly. We can reuse that code. So we eliminate the conflict and drift across the different environments. So it automates the cloud test environment provisioning and ensures the consistency of our different environments and reduce the manual infrastructure setup. So as we are using a predefined infrastructure, enables easy scaling of test environments. So it's cost optimization. So the seamless AWS integrations, multi-cloud and hybrid cloud support. So next we'll see CA and CD, the continuous integration and continuous delivery. It's the iterative process only. So it's the engine of a modern software factory. So continuous integrations, CI means developers merge the codes change back to the main branch frequently. So often daily. So automated test and builds run immediately, catching the integration problems early. So developers merge the code into a shared version control repository frequently, several times a day. It's a continuous integration. So develop, build the product based on the feedback. This is a continuous loop, right? So plan, code, build the test, release, deploy, operate, and monitor. So till plan, code, build, test, and release, the integration happens continuously. After that, the deploy, operate, and monitor is a continuously delivering the product. So automated deployment to production like environments. Production like environments, you're using some virtualized environment or you're using any services from the cloud. So, okay. So each merge triggers an automated build and test process to catch the integration bugs early. So whenever the developers merge the code to share the version control, that triggers the automated test. So continuous delivery like a CD that takes validated code and automatically deploys into the staging or a production environment. So this ensure a product or a software is releasable state. About to release. It's ready to release state. So the key benefits are minimizing the risk of any single deployment because the changes are small and incremental because we are changing it quickly. We are changing in the short period of times. So it is easy to deploy and it minimizes the risk. So on the CI/CD is the backbone, right? It automates integration, testing, and deployment. So continuous delivery ensures that every build is deployment ready. So you're ready to deploy the product in the environment. So the main thing is the source code, build, test, deploy, and monitor, right? Planning, now you have to plan for your products where a developer commits code to the version control system. This action triggers a pipeline. So CI and CD pipeline. So the code is compiled into an executable artifact, it's a Docker or any imagery file. Binary file. We'll see the Docker later. Test automated test run against the artifact to ensure the quality. If test passes, the artifact is automatically deployed to the staging environment for further testing, or you can directly to the production environment. You can deploy the directly to the production environment. The final stage is monitoring, operate and monitoring, involving the monitoring of application production, the feedback looping back to the initial code or a plan stage for continuous improvement. As the Gene Kim said, there are 3 ways, right? The first one is a flow. The flow goes from development to operations. Whenever you get a feedback, so the feedback go to the development stage. They plan again. It's iterated and incremental process. Plan again. They improve the product. Next is containers and orchestration. So containers and the Docker. It's a portable packaging of application and dependencies. Like it works on my machine, it's a problem solver. It's a portable packaging application. The orchestration is a Kubernetes automated deployment, scaling, and management of the container. So the containers, the containers mostly portable and the scalable deployment, specifically Docker certificate standard. Solve age-old problem. It works on my machine. So container packages an application and all its dependents, like its libraries and it configurations into a single portable unit that runs consistently everywhere. The host OS provides the kernel, but the container ensures the application run exactly same, whether the developer's laptop or in the production cloud environment. For example, if I'm a developer and I'm creating some application in my system, okay, it's a portable packaging. So the same container or a package that work on a different environment, also different system. So when you have 100 or thousands of a container, you need a orchestration. That's a Kubernetes. So it's an industry standard for automating the deployment, scaling, and management of those containers to ensure the high availability and efficiently manages the resources. So we have a lot of packages and a lot of containers. We will go for a Kubernetes. Next, we'll see the microservice architecture. So compares a shift from the monolith to loosely coupled services. So there in the diagram, monolithic architecture and microservice architecture. So monolithic, it's a full large applications like UI, business logic, and data access layer. In microservice architecture, we have small services to support for loosely coupling and independent teams. We go for a microservice service architecture. So the benefits are the independent development, deployment, scaling of small services that communicate via APIs. So to support the faster independent deployments, many organizations move from large monolithic applications to microservice architecture instead of a one giant application, right? Like instead of one giant a monolithic architecture that handles everything, you have a small independent services communicating over the APIs. A team working on the payment service. For example, if you have some application that has a payment service or inventory service or any UI design, So the team working on payment service doesn't need to coordinate the release schedule with the team working on the inventory service, right? So this organization decoupling allows for a parallel development. If it is a giant application, all the teams work in a all the teams work together, and each and every team should know what other teams are doing, right? So it's doesn't coordinate the release. So it's loosely coupled for independent teams. The benefit is a team can work, deploy, and scale the specific service independently of. Sorry for the interruption. So with the microservice architecture, we have a small independent services communicated over the API. So the benefit is that the teams can work, deploy, and it drastically increases the overall organization speed. So if the teams working parallelly, it reduces the time, right? So you can give your product on time. It reduces time, so reducing the complexity in the short term. So microservice architecture, instead of using a giant monolithic architecture, monolithic application, we are splitting the services, splitting the teams into a small, loosely coupled and independent teams. Next one is automated testing, shifting quality. So shifting quality left means we have a left and right hand side. So left hand side we have plan, code, test, and build part, right? And right hand side we have a develop, monitor, and operate. So automated testing, the testing embedded with the CI/CD pipeline and unit test. So these unit test and integration test, I hope you studied in the software engineering. So we have studied in the software development life cycle. So goal to catch the bugs earlier, reduce the manual QA bottlenecks. We can use different testing tools like a Selenium, JUnit, and Cypress. So speed is useless without the quality. So we have to assure about the product quality. We have to catch the bugs, and we have to find out the errors. Okay. So automated testing is crucial in CI/CD pipeline. The test must run automatically. So we shift the quality left, meaning we find bugs earlier in the development process. So left hand side we have a development and right hand side up, like this flow. So left to right we have a development and the operation. So meaning find the bugs earlier in the development process when they are cheaper and faster to fix. So after the development part, if we test again, we have if we find out some bugs and errors, we have to do all the things from starting at so planning, coding, building. So we have to find out the bugs earlier, and we shift the quality left hand side. So development part. So this includes the unit test. So developers will write this up. Unit test means testing each and every part. Integration test, we have to integrate different units, different parts. While integrating that product to some environment, you have to test, and end-to-end test the acceptance. So user test, okay, user acceptance test. By automating this, we get a rapid feedback on whether a change broke existing functionally, dramatically reduce the manual quality assurance. So we have to ensure the high quality product. The product is delivered continuously. So every code commit can trigger this switch, providing the immediate feedback. So automated testing, so we get the immediate feedback. Based on the feedback, you have to plan and code accordingly. This should happen in the development phase itself, right? Next is next we'll see the monitoring and observability. Knowing what's happening in production in real time. So we have to monitor. If we simply deploy the product and release the product, if you miss monitoring, the quality will get reduced. And once application is in production, we need to know how it's performing in the real time. Simply we can't host the website or application and stay simply sitting, right? So we have to monitor our observability. So knowing if a system is healthy, the metrics and uptime based on its sample graph on a dashboard, it's a healthy metrics and uptime. Observability is understanding why it is healthy or unhealthy by analyzing the outputs, log, metrics, and phases. So traditional monitoring tracks the metrics like the CPU usage. So we have to check the CPU usage. It's one of the metrics in traditional IT. So sorry, traditional monitoring. So modern observability goes little deeper. It's about understanding the internal state of the complex system by analyzing its outputs. Outputs is the log metrics. So tools like a Graph and a Datadog provide the real-time dashboard and alerting that allows the SRE teams, SRE engineers, site reliability engineers to proactively identify the solve issues before the customer notice. It detects the issues, diagnoses the root causes quickly, and ensures the high availability. That's why we should monitor our system's health, okay, continuously. And if you find out if we detect the issues and diagnose the root cause, we have to change accordingly. So that means that the testing, if anything happens, we go back to the development and continue the process without knowing the customer. Next is security parts in cloud and DevOps. So DevSecOps. Development, security, and operations. So, what's all the message? So I'll answer these questions at the end of the session, okay? May I ask how cloud scalability helps organization and development. Okay. Constructed by system. So shifting security left. So integrating the security practices from the start. So practices the automated, the vulnerability scans, SAST, GAST, compliance checks using the pipeline. So before we'll say about the DevOps security, we have to talk about the cloud security. Okay, so we have seen different services from the cloud computing, right? Service models. So IaaS, PaaS, and SaaS. Can anyone say what are all our responsibilities while we are using the infrastructure as a service? And what are the responsibility for the cloud service providers? Can anyone tell about this? What are our responsibility and what are the cloud service providers' responsibility while we are using a different service, infrastructure, platform, and the software? Am I audible?
Yes, ma'am.
Okay. I think all are muted. So in cloud, if you're using infrastructure as a service, our responsibility. What means the user responsibility to secure your data, your application, your virtual network controls, the operating system, and the user access. So what are the responsibility of the cloud providers? They secure the compute, storage, and physical network, because in infrastructure, they provide the service like compute, storage, and network. So it is the service provider responsibility to secure those all patching and configuration. So our responsibility is you have to secure your data, you have to secure the network controls and the OS user access. So in platform as a service, secure your data, user access, and applications, the same responsibility as a infrastructure. The cloud service provider responsibility, the same as they have to secure their platform, what they are giving to the users. And software as a service, the same, you are responsible for securing the data and the user access. The cloud service provider, they have to secure the compute, storage, network, a physical network, a virtual network, OS, applications, as well as the middleware. Okay. So in software as a service, we are simply log in and using that application. So it's the service provider responsibility to secure their services. Okay. Here the service cannot be afterthought or a final checklist. So a final checklist is the security doesn't come at the end of that phase. Okay. So security used to be compliance checklist, the item right before a release. If you released your product or if you host your website, after that security is not mentioned, right? So you have to secure your product at the earlier stage with a shift security, earlier life cycles. The same here, like shifting security left. That means development part, left-hand side part, and make everyone responsible for it. So this includes the automated vulnerability scanning of a code, content images, static analysis. So SAST is nothing but the static analysis, and DAST is the dynamic analysis in the pipeline, managing the secret securely. So here the security becomes everyone responsibility integrated with the automated workflows. So you can see this in the diagram. We have a DevOps loop. The plan, code, build, test, release, deploy, operate, and monitor. So shift right means it ensures the performance, resilience, and reliability. And shift left ensures the software meets the design. So planning and coding part. So you have to shift our security in the left hand side. So this ensures the compliant securing coding practices without slow down the delivery. Okay. So if you release the product, if you find any leakage or any data breaches, it's a lot of work to do all the things again. So some of the security governance and compliances are there. So ISO standard, NIST, IAM, identity and access management, you can specify who can get the access using those principle IAM. So cloud governance ensure the standardized policies for a security, cost, and operations. As compliance frameworks, the ISO standards are there. GDPR, HIPAA is for health data. So cost governance includes the budget alerts, tagging, resource monitoring. So you have to shift the left security, so security in DevOps. And then what about the cloud security? So here we are integrating the cloud and DevOps. In this slide, we have seen, like, say, DevSecOps. Okay. So I told what are our responsibility and the service provider responsibility where we are using the services like IAs, PAs, and XAs. What if any data breaches happen, any APIs, any data leakage, any disaster happen, how can we secure our mission or work? Can anyone say this? Hi. So next is popular DevOps automation tools. You see, so in the session, I don't give some demo. I just give the definition or a short summary of these development tools. The cloud DevOps tool ecosystem. These are the popular tools categorized by the stage: Jenkins, Ansible, Docker, Selenium, and Kubernetes. So many use the Jira and Azure DevOps for planning. Okay, so for coding, for code hosting and the version control, using like GitHub, GitLab, Bitbucket, and standard. Jenkins, here you can see the logo in this PPT. Jenkins, GitLab and GitHub Actions are popular, the CI/CD. So we use a Docker and Kubernetes for containerization. If a lot of containers are there, we go for the Kubernetes and we can use the Terraform. These tools are important, but remember these are enablers or the methodology. It is important to remember these tools support the culture and process. They are not a transformation itself. So you have to select the right tools for your product or organization specific needs. If we need any help, or if you want to use tools for only planning, you can go for a Jira. For hosting and version control, you go for a Bitbucket and GitLab. Okay, so Jenkins, first we'll see the Jenkins. So a few tools I'll explain. The widely used open source automation software that enables the CI and CD pipeline. So by automating the process of building, testing, deploying a code, and it helps to reduce a human error by improve the software quality. And Ansible is the open source automation tool for IT infrastructure automation configuration management. It helps to automate the repetitive tasks such as provisioning servers, configuring networks, or deploying applications, that will minimizing the risk of a human error. It repeatedly give the provisions and it repeatedly configure the network device. So our work is also low. It will minimize the human error. So Selenium. So it's the most popular tool. Before DevOps, we have seen software engineering in 5-10 years ago. We have seen. So it's the most popular to test automation tool for automating the web browsers. So it enables the tester to write the automated test in multiple programming languages and execute them on the various browsers, helping to reduce errors in the testing process. One of the popular testing tool. And finally, Kubernetes. Docker. Docker is a containerization platform. So it enables the developers to package the application. As I said before, it's a portable and scale up documents, the dependencies, libraries, and configurations. We have to put it in the portable containers. This helps to eliminate the configuration management. So you can use the containers in your you can work it in your own system, or you can use those containers in the different environments. So the application environment remains consistent across the development, testing, and production stages. So next, Kubernetes is a container orchestration platform that automates the deployment, scaling, management of containerized applications. So in Docker, we have a different container. For a lot of containers application, we have go for a Kubernetes. By managing the containers of Kubernetes, teams can ensure that the applications are continuously across the various environments, reducing the potential human errors. So these are all that minimize the human errors. It will help to reduce time. Okay. So final roadmap transformation to the phased approach. We have a different phases: assessment, pilot program, implement CI/CD, expand and scale. So in assessment, you have to identify the gaps and bottlenecks. Pilot program start small, prove the concept, implement CI/CD, automate the core processes, expand and scale, roll out practices across the organization. So in roadmap to transform, so how do you start? It's usually the big bang approaches fails, right? Yeah, phased roadmap is essential. Which one is the first phase, which is the second phase? You have to go to all the phases to complete the cycle. So first, conduct an assessment. So map your current value streams, identify the bottlenecks, and get the leadership buy-in. Okay. So again, start a small pilot program, a small motivated cross-functional team, and a non-critical application to prove the concept and generate internal champions. So we have to start a pilot program. We have to get the team members, a cross-functional team members. The work is the different teams. Next, to implement a basic CI/CD pipeline, automated testing. So as you know, it's a pipeline is starting from plan. Finally, it's operate. You have to find out a different team members for that and automated testing. Finally, expand and scale is an iterative process of a continuous improvement. This phased approach manages risk and builds the momentum. So the cultural change is the hardest part. So as we know, if as a human, if we did something wrong, few, not all, but some won't accept this flaws. They will simply blame others. So technology is easy to implement, but the human behavior and the culture is difficult. For a human, it is little difficult to adapt to the change, right? So it's the primary reason why the transformation fails. So culture is traditional to modern, we have to change, but as a human, our behavior won't change. Some of team members stuck with the traditional IT. Okay, so you must have a strong leadership buy-in, foster a culture of a psychological safety where team members feel comfortable and raising the concerns or admitting the mistakes. So as a person, as a human, if you did something wrong, you have to admit your mistakes. You shouldn't blame others. Okay, so blameless postmortems are here. The focus on the process failure, not people failure. Okay, if any process fails, you have to support other to overcome the failure. Shared goals and collaboration between the development team, operation team, and security, and some business teams are paramount. So the technology part is easy. The transmission is also okay, but we people is a part of a challenge. We need a more time, or it's a difficult to change. Okay, so different teams, like in a DevOps, we have a development teams, operation team, as well as in security, but we have a security team and business teams, right? So we have to work together and have to share the responsibilities. Next, what are the roles are there in the DevOps team? Solving roles: a software engineer, satellite engineer, platform engineer team, and everyone wants a quality and a stability. So in a mature DevOps operation, everyone operates like differently. We might see traditional roles evolve in software engineer. So in a traditional software development life cycle, as I said you before, we have a different phases. Each and every phase, we have a different team members. Okay, so in communication part is the requirements and gathering part, we have a different team members. Planning, analysis and design part, we have a different team members. For coding, we have different team members. For testing and deployment and monitoring, we have a different team members. So in DevOps organization, we have these teams: the software engineer, site-led engineer, platform engineer. So the software engineers who understand the production constraints, are specialized site reliability engineer who focus on the platform reliability and automation. They should know about what's there in what they are doing, and what are the test automatic tests needed. So automation in the sense we have to do all the things automatically with the help of some tools. Some companies create a platform engineering teams whose job is build the internal platforms and the tools that make it easy for a application development teams. So if you have a platforms, so anyone can use the platform as a service, and they can build a application or a product, right? So some companies have a platform engineering team, so enabling the self-services. So the other members can use the platforms and the tools for developing the applications to serve infrastructure and deploy the code securely and reliably. For these are the basic roles in the DevOps organization. And complete the basics of DevOps, we'll see the case study. So Netflix, Chaos Monkey, challenge massive scale, high availability requirement, solution full migration to AWS, a microservice architecture, SRE principle, chaos engineering. So result a high resilience 1,000 of deployments per day. So let's look at the Netflix example. It's a case study. Years ago, a database corruption even looked them offline for days. A disaster pushed them fully into the AWS cloud. Okay, so they fully migrated to the AWS. So the modern infrastructure, they're using the microservices architecture. That means they transform from the monolithic to microservice. So there are a strong SRE culture and embrace the microservices, like intentionally break up the things in production to build the results in the safe manner. This culture allows them to deploy thousands of code changes a day while maintaining the incredible uptime and global scale. Each and every minute and hours, they are changing something in the Netflix, right? So if it is a monolithic or a giant application, it will be very difficult to update changes within minutes. It takes a days or a weeks, and that not be secure. It increases the time. So they changed it to the AWS microservice architecture that splits the work into split the things services into a small part. So parallelly they are updating, parallelly they are doing the works and updating the things. So they are the benchmark for a cloud native DevOps success. They transform the cloud DevOps from the traditional IT. So one of the best prime example. And another prime thing is Amazon. Okay, it's another fantastic example. The Amazon was a famous engineering man. You built it, you run it, right? So this forces the development teams to write the full life cycle of their services. So principle of the Amazon, you build it, you run it, have the full ownership. So solution, the heavy automation, microservice, strong SRE culture within the team, and result of the transformation, the extremely rapid development life cycle, massive global scale for the e-commerce and the AWS platform. So this principle, you build it and you run it, the forces the development teams to own the full life cycle of the services from writing code to maintaining in the production. So starting from a code and maintaining in the final production. This accountability drives a better engineering and automation. Third, use of a DevOps enables a frequent independent deployment, supporting the massive scale. So frequent independent deployments, they can achieve it by the microservices, same as a Netflix. The heavy automation, they totally convert to the automated testing, automated process, everything is fully automatable. And microservices split the work into a small part. So parallelly, they are doing the work. The use of DevOps enables frequent. So supporting the massive scale and rapid feature development of both the e-commerce as well as the Amazon Web Service platform. Okay, so this results extremely rapid deployment cycle. So quickly they are means quite frequently they are updating. So it's necessary, right? It's necessary nowadays. It's necessary for modern infrastructure. So handle a lot of things, right? So massive global scale for the e-commerce and AWS platforms. So finally, we come to the future of cloud DevOps. So what next? So have AI ops, AI in operations automation, serverless computing, multi-cloud, hybrid cloud strategies, platform engineering maturities. So many are there. I have put only 4 points in this PPT. So we are seeing the rise of AI ops, right? AI in the operations and automation. So using the machine learning to analyze the massive amount of operational data, we are using the ML and DL to analyze the data, right? So amount of operational data to predict and even automatically remediate the issue. So here some serverless computing. So there is the same example. Which one is the serverless computing? AWS Lambda Azure functions are another trend. Okay, so abstracting the infrastructure entirely, so developers only worry about the code. They don't need to worry about server, where to put that, where to use the server. They don't worry about that. So multi-cloud and hybrid cloud strategies are becoming more common for flexibility and this field is always evolving. So as I said before, multi-cloud is a single organization using the multiple services from the different providers. The hybrid cloud strategy is the combination of a public and private. So if you for public cloud, we can easily scale up and down, but it is less secure. In private cloud, it is limited. So we can't suddenly scale up and down the resources as per the user need. So we merge a public and private cloud to get the hybrid cloud strategies. These are some evolving future trends. And finally, so conclusion, the cloud provides the agile infrastructure foundation, and DevOps is the culture, process, and automation to leverage the cloud effectively. So transformation is nothing but people, process, and technology. So technology always developing only. So people, we have to adopt structure. We shouldn't stuck with the traditional IT. So embrace automation, collaboration, and the continuous learning. So cloud is an enabler and the DevOps is a methodology. So To overall summarize the lecture, the Agile Foundation with the on-demand and programmatic infrastructure is a cloud on-demand as per you go. And DevOps provides the necessary culture, automation, and lean principle to effectively utilize the cloud's power. And the transformation journey requires a balance of people, process, and technology, as I said. So ultimate outcome is increased stability, speed, innovation capabilities for your organization if you're developing some product. Finally, that's all. We are at the end of the session. And thank you very much for your attention. I hope this lecture provides a valuable insights to the world of cloud DevOps transformation. I have not included that much tools demo. I just giving the simple definition for the demo. You can work with the Terraform. If you want, you can use the Docker and container. Just go through the edit and try to work with this. Okay. So I'm happy to take any questions you might have. Please free to ask.
Yeah, thank you so much for your presentation. And we have some questions from participants already read in the Zoom chat. For this question, could you please explain how monitoring and observability to contribute to the resilience of modern cloud infrastructure?
Can you, your voice? I'm sorry to interrupt. Your voice is breaking. Can you put the questions in the chat?
Already, ma'am.
Already. So, Parvik, could you please explain how monitoring and observability contribute to the resilience more infrastructure? If may ask how cloud scalability help organization handle unpredictable demand volatilities and the operational costs. So cloud scalability mainly for a public cloud. In private cloud, it's a fixed one. You already pay for your organization or your company, and you can use the particular services only. If you want to scale, you have to go for a hybrid cloud. So unpredictable demand, they always should be ready to scale up and down. There are two terms in the cloud, right? Scalability and the elasticity. So automatic scaling up during the heavy load, down during the low usage. So companies pay only for the resources actually they use. So which reduces the unnecessary infrastructure expenses. That's why we have the term pay as you go model. So handling the sudden traffic spikes without the system failure. That's why we go for a cloud, and virtualization helps here. So since scaling is automated and not manual. Okay. Better resource utilization, matching capacity precisely with the actual workload needs. So thus scalability ensures the performance while maintaining the cost efficiency. Because it is not manual, we can't manually scale up and down. Why are you laughing? I don't know why you're laughing. So next, answer the question, Farid, about how monitoring and observability tools contribute. So normally, the providing real-time visibility into the system performance, like latency, resource issues, and failures, we need a continuous monitoring. So if you monitored your product, or am I audible?
Yes, ma'am. Everything is perfect.
Okay, if you're continually monitoring, you can detect the issues earlier through alerts before they become the outages, before delivering your product to the customers. If you monitor it, you can find out the bugs and the errors. So tracing and diagnosing the failures across distributed microservices. So normally the microservices means you're splitting the work into different small work. As distributed system means we have a different systems that interconnected nodes, right? So understanding the root causes using some metrics like logs, metrics, and traces, ensuring the high availability based on the observed system behavior. You can understand your product behavior through monitoring only. So you should observe any changes, any of the mild changes, you have to change your system. So it reducing the downtime through proactive insights and the automated responses. And the next third question, Abdul asked, what mindset should engineers develop to navigate the rapid changes in the cloud and DevOps technologies so continuous learning mindset. So all the engineers should have the continuous learning mindset because the technology evolves rapidly. We have to transform from the traditional to a modern infrastructure. Next attitude is problem solving attitude should the engineers. Is these things are common to all the engineers, not only the software engineers. Okay. So adaptability and flexibility, you have to adapt to the new changes, new platforms and the methodologies. Collaboration and communication is a cross-functional teams, it's the DevOps culture. It's the main thing in the DevOps. Okay, we have to work together. Collaboration and communication is the major thing. Ownership and accountability, automation first mindset to improve the efficiency. Finally, the innovation-oriented thinker to build a better and smarter solutions. I hope you get your answers. Am I clear?
Thank you, ma'am. I guess no one else asking again. Okay. Thank you for your answer. I guess no one else asking again. And before I close this event, for all participants, please open your camera. I will take a picture on the count of three for documentation. Okay, 1, 2, 3. Another one, 2, 3. Thank you for your good cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Miss Sindhu for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least further for collaboration in the future. The visiting lecture for today and here. Hope to see you soon. Thank you and have a nice day.
Thank you, ma'am. Thank you very much.